We start today's class and good morning. And in today's class, as I have already told you, we are going to start with heat transfer, and I'm expecting one or maybe more than one question from this chapter. Remember, this is a chapter that is not in chemistry. Up till now, whatever we have done, whether it was thermodynamics, whether it was kinetic theory of gases, it was all a part of chemistry as well. First law of thermodynamics, second law of thermodynamics, even the third law of thermodynamics. It's not a part of physics, but it's a part of chemistry. Now, this heat transfer and what we did in the previous class, thermal expansion, they are not a part of chemistry. So, we expect that at least one question should come from either thermal expansion or heat transfer, or it could be one question each from heat transfer, because heat transfer is a big topic. And we can expect one question from this topic at least, and it is specific to physics, so there would be question on heat transfer or maybe thermal expansion. Let me just put it on mute. Okay, having said that, let us move on without wasting any time into this topic of heat transfer. And I will be taking the help of the sheet that I have already sent you. You have got that sheet with you, yes or no? The heat transfer one? Okay. So I'll be taking help of that sheet and we will be discussing heat transfer. The first and the foremost thing is, what do you mean by heat transfer? It is nothing but the transfer of heat from one point to the other point. Now, in how many different ways this heat transfer can take place, and I hope that you know the basic things about heat transfer. I'll just go through it. Whenever we talk about the word heat, we've already discussed it in the first day, that heat is a form of energy which transfers from a body at a higher temperature to a body at lower temperature. Instead of saying it in this way, I could say it in a different way. Heat is an energy that is transferred because of difference in temperature. And we have seen that on its own, heat can always flow from a body of higher temperature to a body of lower temperature. It cannot flow on its own from a body of lower temperature to a body of higher temperature. And that is second law of thermodynamics. It tells us the direction of heat flow, or the direction in which a process is possible. Do we remember this? Can I have some raised hands that we remember this? Yes, that was second law of thermodynamics. Second law of thermodynamics tells us which process is possible. I told you the example. I drop this pen drops down, some heat is produced, some noise is produced, but that doesn't mean that if I produce noise here and if I give it heat, it will go up. So only one direction is possible. Second law of thermodynamics tells us that heat can only flow from higher temperature to lower temperature. Now is the time that we understand how it flows. We have already seen it flows. If a body is at higher temperature, a body is at lower temperature, then heat will flow. Whatever heat is lost by one body, same heat is gained by the other body. That was in the chapter called calorimetry. Heat loss is equal to heat gain. Do we understand this? Do we remember heat loss is equal to heat gain? Now what we are going to see is how this heat is going to get transferred, and there are three ways, three modes, three different ways of heat transfer. What are those three different ways? The first way, the first tarika in which the heat is getting transferred is conduction. The second way is known as convection, and the third one is known as radiation. And I'm sure that you know what is conduction, convection, or radiation. This conduction is the process in which the material takes an active part by molecular action and energy is passed from one particle to another particle. Here what happens is, it basically takes place in solid. We will have a table and we will discuss that table. How does conduction take place? I'll just explain to you in very short. Please note it down. It will be there in the table, but again, see, this is a rod. Let me get this thing off and let me get myself on board. This is a rod. Now let us assume that one end of this rod, this one, the tip one, is at a higher temperature. I put it near fire. The other one is at normal temperature or at a colder temperature. Now what happens? After some time, if you are holding it from here, you will find that this end also gets heated up. Remember, this end of the rod is not in touch with the fire over here. Do we understand this? Now, the question is, how am I feeling or why am I feeling hotter at this end? Well, I'm feeling hotter at this end because heat is getting transferred from this end to the other end. The mode in which, the process by which it transfers is known as conduction. And this is the mode of heat transfer that takes place in solids. Now, how does it take place? It's very simple. This rod has got a large number of molecules and atoms which are oscillating and vibrating in their positions. They are in constant motion in their positions. Now, the end which is at a higher temperature, these molecules, now temperature relates to kinetic energy. We have seen it, kinetic theory of gases. More the temperature, more the kinetic energy. Do we understand this? Now, more the temperature, more the kinetic energy. Remember that. So these molecules here at this end will have higher kinetic energy. These molecules at this end will have lower kinetic energy. But these molecules at this end will collide with their neighboring molecules. When they collide, they will transfer energy to their neighboring molecules. These neighboring molecules will then collide with their neighboring molecules. These neighboring molecules will collide with their neighboring molecules. And hence, in this way, by their collisions of these molecules, this energy is going to get transferred from this end of the body to the other end of the body. Do we understand this? Now, when this energy is getting transferred, remember one thing, no molecule is getting transferred. No molecule is getting transferred. What it means? The molecule which is at this end is not going to move from this end to the other end. The molecule does not move. It only vibrates and collides with the neighboring molecule, and the neighboring molecule collides with the neighboring molecule. The neighboring molecule collides with the neighboring molecule, and hence, in this way, energy is getting transferred. The molecule itself is not moving. Do we understand this? From the hotter end to the colder end. This mode of heat transfer is known as conduction, and in which type of body this conduction is having the maximum possibility, or which type of body will have heat transfer by conduction? It is only a solid body in which you will have conduction as the mode of heat transfer. It is only a solid body in which you will have conduction as the primary mode of heat transfer. Why not in liquids and why not in gases? Question. Why cannot conduction take place in liquid and gases? The answer is conduction takes place in liquids and gases, but it is very, 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 very slow, and it is not the main mode of heat transfer. Conduction takes place in liquids and gases as well, but it is not the primary means of transfer. Now the question is, why conduction cannot take place, or why conduction is not very fast, or why conduction is very slow in gases and liquids? Can you give me the answer for this? Why conduction does not take place in liquid and gases? The answer is, in a solid body, in a solid, atoms are very tightly packed up. Atoms are very tightly packed up. They are very close to each other. So when they vibrate, when they oscillate, they collide with the neighboring molecules easily. The collisions are very high. But in case of liquids, the liquid are farther, the molecules are farther. In gases, they are very far. So their probability of colliding and transferring energy is very less, and therefore conduction is very less in liquids and gases. Do we understand this? Conduction is the primary mode of heat transfer in solid because here heat is transferred by collision. Solids, molecules are very closely packed, collisions are more, energy is transferred very fast. In liquids and gases, conduction is very slow. Do we understand this? And remember here, molecule itself does not get transferred from one end to the other end. Molecule is not getting transferred. It is only the energy by collision which is getting transferred. That is all about conduction that I have told you. I hope you have written the important point. The important points will be coming up in the tabular sheet as well, columns as well, but this is all you need to know about conduction in theory, and there could be a question coming from this itself in your exam. Now let us move forward and go on to see the other mode of heat transfer. And the other mode of heat transfer is convection. Now, what is convection? Have you seen convection anywhere? The question passes on to you. Have you seen convection? Can you give me an example of convection? Have you seen convection happening? Yes? You can raise your hands if you know that you know the example of convection. If you don't know, no harsh feelings. Yes, you know what is convection? Okay. What is the simplest example that you can give about convection? Now, the first thing about any mode of heat transfer, the first thing that you should know is how the heat is getting transferred. How the heat is getting transferred. If you understand how the heat is getting transferred, you will be able to understand where it will take place. For example, in conduction, heat is getting transferred by collision. That is why it happens mostly in solids. Liquids and gases is very less, very slow, very less. Now, convection, what happens? I told you in conduction, molecules do not move from one end to the other end. Molecules do not move from one end to the other end. Now, look at convection. Now, let me give you an example of convection. Right now, it is summertime, but let us imagine that it is winter. I don't know how harsh is the winter down there in your place, but out here, and as you go north, more north, the winter gets harsher. We have very cold winters. Now, in villages, when it gets very hot, when it gets very cold, what do? You burn some pieces of wood and you make a bonfire. Do you understand bonfire? Bonfire or a chula or a gas, anything. You make a bonfire, you put all this wood and you light it up. You fire it up. Now, when you're feeling cold, you do not put your hands inside that fire to get it warmer. Obviously, if you put your hand inside this fire, it will be burned. What do? The fire is somewhere here and you put your hands on the top of it, very far away from the actual fire, very far away from the actual fire, but you still feel warm. Yes or no? That means somehow heat is getting transferred from that fire, which is far away, to your hands and your body, which is still not in fire. That is, there is some mode of heat transfer which is taking place, and that mode of heat transfer which is taking place right now when you are getting yourself warmer in a fire is convection. Convection is the mode of heat transfer that takes place basically in liquids and gases. This, gentlemen, takes place in liquids and gases as it is already mentioned. Now, in this mode of heat transfer, and that is how you can differentiate it from conduction, there is an actual motion of particle of the medium. That means what is happening, if this is my bonfire, let me create a bonfire here. This one will create a good bonfire. If this is my bonfire, I put two wood and I have lit it up. Now, this is my bonfire. Here I have created a fire, and let me get myself on the screen. This is my bonfire. I have created fire over here. So what happens? Here it is very hot. The air surrounding this is very hot. Now, you know from your previous knowledge, hotter air is lighter, it will go up. Colder air or colder air is denser, it will come down. Do we understand this? Yes or no? The air gets hotter, which is near to fire. It gets very hot and therefore it goes up. Colder air comes down, and this is the hot air that you feel when you put your hands above this. So basically what is happening here? The medium, which is air, if there is no medium, if you make a bonfire at moon, you cannot burn something on moon because there is no oxygen. But let us say that you have some sort of a chimney which has an oxygen inside it and you burn it. And even if you try to put your hands on the top of that, you will not feel hot or warm because there is no air. Conduction cannot happen without any medium. Do we understand this? This is my bonfire. It heats up the air surrounding it. The air moves up. There is an actual motion of particles. Here the particles are air particles. Here there is an actual motion of air particles, and this mode of heat transfer is known as convection. It cannot happen in solids because in solids they are very tightly bound. They cannot move from one end to the other end. Therefore, convection is not possible in solids. Do we understand this? Another example of convection that you have always seen in your daily life is your boiling of water or your boiling of for milk. Let us suppose that this is a tumbler. This is a beaker in which I am boiling milk. Now this is my gas stove, and I put this gas stove, I put this beaker. Now how does this milk or water gets boiled up? Now the first thing is the bottom part will get hotter. Now it will conduct, because this is a solid body, it will conduct heat. The side walls will get hotter, they will also conduct heat. But how does water boil or milk boil? The layer of the liquid which is nearest to the bottom, the layer of the liquid which is nearest to the bottom will get heated very fast because it is just near the fire. Now when it gets heated up, it becomes less dense. It will move up. The colder water or colder milk will, the hotter water or hotter milk will go up, and the colder milk will go down. This colder milk will goes down, will get heated up. It will again come up, and that is how this entire thing is getting heated up. When it gets heated up, it goes up, and the colder water or colder oil or colder milk replaces it. There's an actual transfer of particles from one point to other. Hotter things are moving up, colder things are moving down. This is happening because there is gravity on Earth. Moon, it cannot happen. You cannot boil anything on moon. There is no gravity. Heavier things will not go down and lighter things will not go up. Convection. The mode of heat transfer will take place on Earth because of gravity. Because hotter things go up and colder things go down. Hot balloon, hotter air, lighter air, that is why it goes up. Colder air comes down. This mode of heat transfer is known as convection, and it requires a medium, and that medium can be a liquid, boiling of water, or gas, your bonfire. Do we understand this? Yes or no? Okay, that was about convection. Now we move on to the third mode of heat transfer, and the third mode of heat transfer is radiation. Now the question that comes is, conduction takes place in solids. It takes place in liquids and gases, but it is very less. Convection takes place in liquids and gases. It cannot take place in solid because particles cannot move. What about radiation? What type of body can transfer heat by the process of radiation? What all bodies can transfer heat by the process of radiation? Is it solid? Number one. Is it liquid? Number two. Is it gas? Number three. Or is it all of these? And how is radiation different from conduction or convection? Any ideas? If you have any idea, you can raise your hands. If you don't have any idea, you can get idea. And how are you going to get idea? I am going to give you the idea. Yes. Do you know this? The mic is still not working. Bacha, is the mic working? That bobu thing that you have in your hand, is it working? And throw it out of the window. That would be a better thing to do than keep something which is not working. And better throw it out the window so that we can have something new. Okay. The mic doesn't work, but my mic does work. So I am going to tell you. What is radiation? Now, radiation can take place whether the body is a solid. This is a solid body. This is transferring heat by the process of radiation. Yes, it is. Take the example of a liquid body. hot water in a beaker or very cold water in a beaker, if I keep very hot water here in my room, after some time it will come to the room temperature, yes or no? If I keep a very chilled bottle of a cold drink, I don't like cold drinks anyways. If I keep a very chilled bottle of a cold drink here, after some time it will come to room temperature. That means it has lost heat or it has gained heat. By what process that water or cold drink or whatever it is had lost or gained heat? It is by the process of radiation. If I heat up this pen, obviously it will melt, but let us suppose that if I increase the temperature of this pen, now let us forget about pen. I'm heating the water in a beaker. That beaker also gets heated up, but after some time it will come back to its room temperature, yes or no? That means whether a body is solid, whether the body is liquid, or whether the body is a gas, it can transfer heat by a process which is known as radiation. Now, how does heat get transferred by this process? We may not know. It is not in this course for us to know. But what is very important for us to know that this mode of heat transfer is the quickest way of heat transfer, and it does not require any medium. So this does not require any medium. So this mode of heat transfer can take place even on moon. Sun is very far away from us. Between the sun and earth, there is no atmosphere, there is no gas, there is complete vacuum of space. But sun is emitting thermal radiation, heat energy. That is what heating up the earth. Global warming. Earth is getting heated up. It's very hot now. Why it is very hot? Sun is so far away from us. That is giving us radiations. That is radiation, the third mode of heat transfer. That is giving us radiation, thermal energy, heat energy, light energy. This heat energy, light energy, thermal radiation is coming to us, heating us up, heating the earth up. The process by which this happens does not require any medium because there is no air in between us and the sun. This mode of heat transfer is known as radiation, and it can take place whether the body is solid. Sun is a solid body. Whether it's a liquid body or it's a gaseous body. Sun is nothing but a gas, big sphere of gas. Do we understand this? Yes or no? Conduction, convection, and radiation. I'll give you a minute if you want to note down what is there on the screen in front of you. A minute to minute. Have you noted this down, everyone, bacha? Now comes the table that I was. What happened? Not noted down? You need more time. Okay. Shall I take you back to the previous screen? Okay. Okay. Just a moment. Just a moment. I'll take you back to the previous screen. I thought that you might have written it. Sorry. Now, can you note it down? Please note it down, bacha. So, we have seen the basic definition of heat transfer, and I hope you have noted it down. Now is the time to make this table, and every point in this table is telling you the subtle differences between conduction, convection, and radiation. It is all that you need to know about the theoretical aspect of conduction, convection, and radiation. This table is in your sheet, but I would expect you to write it down with your own hands. Conductions, not conductions, it is conduction. Heat transfer takes place because of temperature difference. See this pen, one end is at a higher temperature, the other end is at a lower temperature. So it takes place because of difference in temperature. This, gentlemen, takes place because of density difference. Hot air goes up, colder air comes down. Do we understand this? Then the process of radiation, it does not require any medium. Whether you on moon, you can enjoy the heat of sun. Moon gets heated very fast in the daytime. The temperature is very high because there is no atmosphere to save you. If you go on moon someday, maybe your generation would be landing upon moon and you would be setting up bases on Mars. Well, do not forget my lecture there. How does the heat get transferred in conduction? Because of the collision of molecules, they do not move from one end to the other end, but they do and energy gets transferred. Convection, actual motion of particles, it is in the form of rays or waves or electromagnetic radiation, EM waves, electromagnetic radiation. Have you heard the term of electromagnetic radiation? Light is an electromagnetic wave, yes or no? Radiation is basically electromagnetic wave. Do we understand this? This mode of heat transfer takes place basically in a solid body. In liquids and gases, conduction is there, but it is very slow. This mode of heat transfer can only take place in liquid and gases. Radiation involves all. Every body radiates. And we will prove that every body radiates. Even you sitting right now are radiating. It's a slow process. Oh, it will take time. If this end is at higher temperature, it will take time for you to feel the heat on the other end. It will take time. Convection is also slow. As soon as you burn the fire and you put your hand on top, you will not feel the heat. It will take some time. But radiation is the fastest process because this is in the form of electromagnetic radiation, and electromagnetic radiations or electromagnetic waves or light travels at the speed of light, and the speed of light is 3 into 10 raised to the power 8 meter per second. So this is almost instantaneous. Conduction is irregular. See, my pen, it can be of any shape. It will transfer in irregular paths. Convection is also irregular. You put your hands on top, you will feel heat. You put your hands on the side, you will feel heat. You put your hands like this, you will feel heat. It does not move in a straight line. But radiation, electromagnetic wave, it moves in a straight line and it causes shadow. Do we understand this? Everything about conduction, convection, and radiation is given in this one sheet, this one PPT or whatever you call it. I hope that you note it down. I'll give you a minute to note. So, I hope we have understood the difference between conduction, convection, and radiation. Now is the time to deal with them separately. We'll be dealing with conduction and radiation because convection is not a part of your curriculum. So the first heading is thermal conduction or simply conduction. The first thing is its definition. Now here the definition is given very precisely, very exactly, and this is the definition that you must understand. What is conduction? It is a process by which heat is transferred from hot part or cold part, from hot part to the cold part. Heat can only transfer from hotter end to the colder end, not from the colder to the hotter. Second law of thermodynamics. From the hot part to the cold part through the transfer of energy from one particle to another particle without the actual movement of particles from their equilibrium position. This process of heat transfer takes place only in solid body. The heat process of heat transfer will keep on going unless the two ends of the body come to the same temperature. So if this is the hotter end which is kept on fire, you will start feeling the same temperature of this colder end. Up till that time, the heat will keep on getting transferred. If there is temperature difference, the heat will keep on getting conducted. So for conduction, we require temperature difference. Do we understand this? So you'll write the main heading conduction and you will write these points, important points. The definition of conduction is here. If you have written it 2 or 3 times, you may not write it. You can just mark it. So I'll give you a minute to mark it. So now, since we have noted down the definition of conduction, this is the time that we understand two very important terms in conduction. Not two, it could be one term actually. But to understand the first term, you must understand the second term. And the first term that we are going to understand is known as variable state, which is not of importance to us. The term which is important to us, which we are going to study, is steady state. But to understand steady state, we have to understand what is a variable state in conduction. Now listen to me very carefully because you may not be able to write it. So listen to me very carefully. What is a variable state and what is a steady state? And then I'll give you time to note what is there in the sheet. So what is a steady state and what is a variable state? And again, I come in full screen. We're talking about conduction. This is my rod. This is the hotter end and this is the colder end. Now, as soon as I put this rod between the hotter end, this hotter end could be a hotter body. So let us take it like this. This is a hotter body at a higher temperature. This is a colder body at a lower temperature. Now, this hotter body is going to transmit heat to this colder body. They can obviously do it by radiation, but let us forget about radiation. They can also do it by convection. The air here will get heated up and this heated air will move here. Let us forget that. Let us now concentrate on how they are going to be transfer heat by the process of radiation. So what do? I put a rod in between these two. Hotter body, colder body. Now heat is going to get transferred through this rod and I have insulated this rod. So there is no heat loss by radiation. All these things are there. Now, how is the heat going to get transferred? This is the end which is in the contact of the hotter body. This will get heated up first. This will get heated up and the other end is at a less temperature. So heat will be transferred from this end to the other end. Now, when heat is getting transferred from this end to the other end, some heat will be lost. Not lost. Some heat will be absorbed in the sections which are coming in between. So the sections which are coming in between are also getting heated up. Do we understand this? This rod, this is body at a higher temperature. This is body at a lower temperature. When heat gets transferred, the different sections also get heated up. As time goes by, these different parts will get heated up more. Now let us take one condition, that this body is at a constant temperature. This hotter body is at a constant temperature. This colder body is also at a constant temperature. So this body, the temperature is not going to change. This body, the temperature is not going to change. Now I put this between these two. Heat will start to flow from hotter to the colder end. In the beginning, some heat will be absorbed in the intervening section. But after some time, you will find out that the different sections of this rod, their temperatures will remain constant. Do we understand this? After some time, the different sections of the rod will come to the same temperature and their temperatures will not change. This state is known as steady state. This state is known as steady state, where the temperature of the different sections of the rod are constant. Do we understand this? Before that, the temperatures of the different sections were keeping on changing, and that state is known as the variable state. This was my explanation of the variable state and steady state, and this is what you will find written in the notes. Variable state, it is the state in which the temperature of each cross section of the rod increases with time, but the temperature of any cross section of the rod decreases with increasing distance from hotter end to the colder end. Now it might look very complicated when you write it, but it is not very complicated, and I'll show it to you. What is a steady state? When the temperatures of each cross section of the bar becomes constant but different for different cross section area, the rod is said to be in a thermal steady state. Can you note down these 2 points? And I will make you one diagram that will tell you everything about this. So I'll give you a minute to note this down. Note this down. Let's move ahead and try to understand what I mean by a variable state and what I mean by a steady state. What I have drawn here is a rod between two ends, theta 1 being the hotter end and theta 2 being the colder end, theta 1 more than theta 2. And I have drawn in green the different cross section 1, 2, 3, and so on. Do you see this? The different cross sections from the hotter end to the colder end. Now, what happens? As soon as I fix the rod between the hotter end and the colder end, the different sections 1, 2, and 3 will start on getting heated up. This temperature T1 will be more than T2, will be more than T3, and so on. So basically what it means, temperature will change from hotter end to the colder end. The points which are closer will be hotter and the points which are farther will be cooler. Do we understand this? That was one part of which was written in the sheet. The temperature goes on decreasing from the hotter end to the colder end. Sections which are near to the hotter end will be hotter. Sections which are nearer to the colder end will be colder. Now what happens is when I start this conduction process, this temperature T1 will keep on increasing, temperature T2 will keep on increasing, temperature T3 will keep on increasing. So T1, T2 and T3 will keep on increasing. That means different sections of the rod will be at different temperatures, but that temperatures will keep on increasing. This state is known as the variable state. Do we understand the variable state now? The temperatures of the different sections T1, T2, T3 and so on will keep on changing. This state is known as the variable state. But after some time, what will happen is T1, T2, T3 will become constant. T1, T2, T3 and so on. When they become constant, when they stop changing, that state is known as the steady state, and this is the state in which we are going to study convection, because in variable state convection becomes a lot difficult to study. So we will be doing it only in the steady state. In the steady state, the temperature of the different sections, the temperature of different sections are different. Point number 1. I will note it down point wise. I'll give you a minute to draw this diagram, and after that I will continue on with my discussion. A minute. So basically what I was telling you is, in steady state, the temperature of different section will be different, but that temperature will remain constant. Now what I am going to do is I am going to note down on the sheet the important points about steady state, and you will be noting down together with me. So the heading is steady state. Number one, in steady state, what is going to happen? Temperatures of different sections would be different, but their values will remain constant with time. But their values will be constant. Do we understand this? Because I have used two opposite terms. I have told you that they are different, but they are constant. That means different sections have different temperatures, but their values are constant. Do we understand this? Okay. No heat is absorbed. Delta Q means heat. No heat is absorbed in the section. That means whatever heat is entering one section, the same amount of heat is leaving the section. If I draw a section here, section number 1, if I tell you delta Q amount of heat is entering this section, same amount of heat will be leaving this section. Do we understand this? Whatever heat is entering this section, the same amount of heat will be leaving this section. Do we understand this? That means what will happen? The rate of heat transfer, delta Q by delta T, the rate of heat transfer, or dQ by dt, or you can call it rate of heat transfer. Rate of heat transfer or rate of conduction will be constant. Do we understand this? Do we understand this, that the rate of heat transfer is constant, or the rate at which heat is getting transferred will be constant in a steady state? The next point is temperature gradient. And what is this temperature gradient? I will tell you just now on only. Temperature gradient is constant. Now what is this temperature gradient? I am going to explain to you just now. Don't worry. What is this temperature gradient? What is this temperature gradient? Let me draw that rod once again. This is the rod that I had drawn. This end was at temperature theta1. This end was at temperature theta2. Theta1 was more than theta2. Do we remember this rod? Do we remember this rod? Let us suppose that the length of this rod is L. Let us suppose that the length of this rod is L. Now what is temperature gradient? Temperature gradient. If I find out the value of theta1 minus theta2, if I find out the value of theta1 minus theta2, which is nothing but the difference in temperature, and divided by the length L, divided by the length L, divided by the length L, this value in pink is known as the temperature gradient. Difference in temperature divided by the length. Do we understand this? Difference in temperature divided by the length. Do we understand this? This thing is known as temperature gradient. If I take a very small section, this very small section has a length dl, and this has a temperature difference of d theta, small temperature difference of d theta, small temperature difference of d theta, length is dl, then I can say that this will be equal to d theta by dl when the body comes in steady state. That means this d theta by dl is nothing but the temperature gradient of this small section. D theta by dl, small change in temperature divided by small length, or theta 1 minus theta 2 divided by L, or I can also write it as, wrong color, I can also write it as delta theta, small change in temperature divided by delta L, the difference in length. All these terms are known as temperature gradients, and all these terms are equal in steady state. Do we understand this? I'll give you a minute to note this down. If you have any doubts, please raise. Since we have understood now what is variable state and what is steady state, in steady state, temperature of different sections remain constant. There is one term which comes normally in the exam, and that is known as your diffusivity. Again, such questions, if they come, if you don't know the meaning of that term, you are gone. You will get -5 or 0. But you should be getting +4 in those questions because it's a very simple question. What is diffusivity? The ratio of thermal conductivity. Now, what is thermal conductivity? We'll come to it. To thermal capacity. We know thermal capacity, mass into specific heat. Do we know this? MS, thermal capacity, heat capacity. The chapter on specific heat, M into S. Do we remember that? Thermal capacity per unit volume. So it is mass into S divided by V, and therefore it becomes rho. Thermal capacity per unit volume. The ratio of thermal conductivity is not ratio, is thermal conductivity. The word ratio is wrong because it is not a ratio. It's known as diffusivity. It is a measure of the rate of change of temperature when the body is not in steady state. So diffusivity is nothing but the measure of the rate of change of body when it is not in steady state. You can just note down this definition. I'll give you a minute to do this. And let's move on to the equation of thermal conduction. And what is the equation of thermal conduction? I hope you can see this. This is my water end, which is at temperature T1. Do we all see this? Do you see this? Temperature T1, hotter end. Temperature T2, colder end. The length of this rod is L. The area of cross section is not mentioned. The area of cross section, this area of cross section is A. If I write the equation for heat transfer, the rate at which heat is transferred, dq by dt, where small t stands for time, dq by dt is K, which is a constant, which is known as thermal conductivity. It depends on what type of material the body is. If the body is a good conductor, then the thermal conductivity will be very high. Do we understand this? A is the area of cross section, L is the length, T1 minus T2. In fact, T1 minus T2 divided by L. Do you remember what is T1 minus T2 divided by L? Tell me. What is T1 minus T2 divided by L? It is your temperature gradient. Do we understand this? The same equation is written in terms of temperature gradient d theta or dt by dl. Do we understand this? Why this negative sign is coming? Because as I move from higher end to the lower end, the temperature falls down and therefore this negative sign is given. So what you got to do is write this equation, equation number 1 and equation number 2, and you write all these terms. I will give you a minute to do this. So we have seen two types of definition. One is in terms of d theta by dl. One is in terms of T1 minus T2 divided by L. You must understand that both the equations are same because we have written both of the equations in steady state. Do we understand this? That both of the equations are written in steady state. Both of the equations are written in steady state, and here is a short thing about temperature gradient. If you want to note it down in your sheet. What is temperature gradient? The decrease in temperature or the change in temperature with the distance or with the length is known as temperature gradient. The hotter end temperature is more, the colder end temperature is less. Temperature gradually decreases from the hotter end to the colder end. d theta by dl or dt by dl, how it is changing with distance, is known as temperature gradient. It is denoted by minus d theta by dl because temperature decreases, and that is why this negative sign comes. In the direction of heat flow, heat flows from higher end to the lower end, temperature gradient is going to decrease. I'll give you a minute to note this thing down. Your time starts now. Then let's move on to the next thing, which is thermal conductivity K. And I have seen a lot of questions asked on this particular topic. What is thermal conductivity? Thermal conductivity K. It depends on the nature of the material. Gold will have different thermal conductivity, silver, iron, copper, aluminum, brass. K is maximum for silver and minimum for freon. The order of thermal conductivity, silver is more, aluminum is less. You don't need to know this. You need to know what is the unit of thermal conductivity. This is the unit for thermal conductivity. The dimension M1, L1, T minus 3, theta raised to the power minus 1. Remember the units and remember the dimensions. I'll give you a minute to note these things down. Let's move on to some golden key points that you must remember. For an ideal or perfect conductor, if something is ideal, a perfect conductor, the value of K or thermal conductivity should be infinite, should be very, very large value. So basically this K tells us how good or how bad the conductor is. For a perfectly bad conductor, or what should I say, an insulator, for an insulator, the value of K will be 0. For cooking the food, low specific heat and high conductivity. So your utensil should get heated up very quickly. That means low specific heat. If it takes a lot of time to heat it up, well, you will be wasting a lot of gas, cooking gas on heating the body. So it should be having low specific heat and high conductivity. Why high conductivity? Because if it does not conduct, your food will not get cooked. So for your cooking utensils, low conductivity, no. High conductivity and low specific heat must be the requirement. I will give you a minute to note this down. Please note it. The next thing that we are going to discuss now is the Wiedemann-Fons-Lorentz law, and I have seen one or two questions coming from this. This is not a part of JEE Mains. This is specifically for NEET. What is this Wiedemann-Fons-Lorentz law? At a given temperature, it states that the ratio of thermal conductivity to electrical conductivity, if we can call this a ratio, the ratio of thermal conductivity to electrical conductivity is constant, or I can say K divided by sigma into T, where T is the absolute temperature. This value is a constant. K stands for thermal conductivity, sigma stands for electrical conductivity, and they are referring to almost similar things, not similar, almost similar. Thermal conductivity, electrical conductivity, heat current, electric current, all these things are somehow somewhat similar, and we will see more similarity in tomorrow's class. Right now you will note this down, not on the sheet but in your notebooks. Okay, you may not remember the name of this law. That is not important. K divided by sigma T is a constant. That is what you got to remember. Please note it down. I will give you a minute to do this. So this takes us to the last point of this class. Again, you must understand that whatever points we have discussed, some of these points, in fact, most of these points, we have not done a single numerical today. Most of the points are theoretical, and more important point here is in this chapter, we expect more theory questions rather than numerical. Numerical, if it comes, it will probably be in the Newton's laws of cooling wala zone or in the conductivity wala zone. So we will be solving a few numericals, obviously, but most of the questions in this particular topic are theory based, and that is why we are spending so much time in theory. And this is one more statement, I should say, one more statement that you must note again. The name of this experiment is Ingenhouse's experiment, which is not important for you. No one is going to ask you what is Ingenhouse's experiment. What you got to understand is the statement: if several rods of different thermal conductivity are coated with wax, and one end of all these rods are maintained at the same temperature, then the length of the rod up to which wax has melted, is proportional to the square root of L1 by L2, will be proportional to root over K1 by K2. This formula is what we require and nothing else. Up to what length will the wax melt? That is all that we require. L1 by L2 has to be equal to root over K1 by K2. That is all we require. I'll give you 2 minutes to note this formula down. Well, I hope you have noted this down, and that takes us to the end of this class. Before ending this class, I must let you give a quick recap of what we have done in today's class. In today's class, we started with the concept of heat transfer. We have seen that there are three modes or three types of heat transfer: conduction, convection, and radiation. Conduction takes place in solids, convection takes place in liquids and gases, and radiation takes place for everyone. We have also seen the formula for conduction. We have seen what do you mean by temperature gradient, change in temperature divided by the small length d theta by dl, or total change in temperature divided by total length. We have also seen that in steady state, different sections of the rod, they have different temperatures, but these different temperatures, the values will remain constant, and this is a steady state that we are going to study. We have also seen that thermal conductivity and electrical conductivity ka ratio remains constant at a given temperature, how closely they are related to each other. Thermal conductivity, electrical conductivity, electric current, electric resistivity, thermal resistivity, all those things we will discuss in the next class. We will be solving some questions also, and we will try to wind off to a conduction, maybe in tomorrow's class or maybe day after tomorrow. I'll see you in the next class tomorrow at 9 o'clock. Take care. Have a nice day. And if you have any doubt, please come up. Class from my end is over. Bye bye.